In today's video, I want to talk about the multiplication rule for exponents. Now, what's the multiplication rule? The multiplication rule is, well, let's just see. It helps us out when we're multiplying exponents. So what if I have something like, I don't know. I like to stick with 2 and 3s. So what if I do 3 to the third times 3 squared? What would that be? Well, just as in the last video or in some other videos, I'll show you a few ways you could look at this. You could think about it like this. Well, I have 3 3s here. So 1, 2, 3, right? 3 to the third is 3 times 3 times 3. And I have 2 3s here times 3 times 3. And so I could multiply all of this, right? 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. 81 times 3 is 243. So I could think about it like that. I could also think about all of these 3s as 1, 2, 3, 4, 5 3s. And then I could, use a calculator or do this again and say that 3 to the 5th is 243. Oops, not 245, 243. So, do you notice something? 3 to the third times 3 to the second is 3 to the 5th. Well, maybe you notice that 3 plus 2 equals 5. So if I'm multiplying, all I have to do, as long as I have the same base, remember here the base would be 3, then I add my exponents. So I add 3 and 2. So the rule then is, the multiplication rule is if I have x to some number, the m, times x to another number, that's equal to x to the m plus n. Okay, maybe just one more example. Keep things moving. If I had 3, let's do something different, 6 to the 7 times 6 to the negative 3 times 6 to the negative 2. What would that be? Well, nothing changes just because I have negative numbers or because I have 3 numbers. It's just 6 to the 7 plus negative 3 plus negative 2. 7 plus negative 3 is 4. 4 plus negative 2 is 2, so that would be 6 squared, which is 36. And that's your answer. Maybe one more. I know I'm getting kind of carried away here, but that's fine. What if we have x to the 4th times x to the 10th? Right, just like before, I have the same bases, so 4 plus 10 is 14. So that would be my answer. It would be x to the 14th power. So this is the multiplication rule of exponents. Now, it gets a little more tricky when I start using what we call monomials. And a monomial is just a fancy term for an expression that has multiple parts. So for example, or just a singular expression, I guess. That's not really right either. A monomial is a term. Maybe it's easier to write examples. An example of a monomial, x squared would be a monomial. 3y cubed would be a monomial. 4 is a monomial. Things that are not monomials would be like x plus 2. That's not a monomial. Or x squared plus 4. That's not a monomial. Okay, so what happens if I'm multiplying monomials? Monomials. Like this. What if I have 3x squared times 4x? Well, I multiply my numbers and I multiply my unknowns. So this would be 3 times 4 times x squared times x. Well, 3 times 4 is 12, and x, this is like, you could think about it like x to the first power. So 2 plus 1 would be x cubed. So that would be your answer, 12x cubed. I just multiplied 3 times 4, and then I multiplied x squared times x. What if you had something a little more tricky? What if you had 2y to the 4th? That's not what I want. Oops. What if you had x squared times y to the 4th times x cubed times y to the 5th? What would that be? Well, x squared times x cubed, I multiply my like terms, and y to the 4th times y to the 5th. 2 plus 3 is 5. 4 plus 5 is 9. And that would be my final answer. So if you're multiplying together monomials, then just take your like terms and multiply them. And that should set you up. Hope this was a helpful explanation of the multiplication rule. See you in the next video.